Joseph, Happy New Year's. Congrats on the first. I forgot to update my YouTube chat. Oh, wait, is this going to be a... Okay, yeah, good. Okay. I think we're good. The task that I want to work on today, assuming we don't get a question from chat, is, well, okay, no, let me... This is code that I wrote to simulate the reaction-diffusion equations, and you get cool-looking stuff like this when you graph your results. It's kind of weird how the edges are behaving. That's kind of bothering me. But I think it's... Like, I got the homework right, so I think it's supposed to look like that, but I don't know. 19th application? A uni in China and one in Spain? Oh, that's sick. 19 applications is so many. Music's a little loud. Holy crap. So the first thing that's running through my head is that the first time I tried applying for PhDs, I applied to 10 different schools because one of my professors recommended that I just apply to a lot of schools. But then one of my other recommenders, oh, Esco, thank you so much for the raid. I hope your runs were good. Welcome in, people. If you're confused by what's happening, I am currently doing a math stream because I'm actually a math graduate student, but I also play DayZ. Brendan's Esco, I think only once, but Esco's awesome. That's gonna be the last application, Joseph. Okay. Yeah, no. I annoyed one of my recommenders when the number of schools that I applied to. Hey, Papadoria. So like hearing you saying 19 is making me wonder like if you're I assume you have to get recommenders also, right? Better than other times? All right, hell yeah. The last 2 times I played Namalsk, they have not gone well, and so I've lost all of my confidence. So yeah, basically the theme of the stream is I take like people's math questions from chat. But if there's a question, if I have my own thing to work on, and right now the thing I'm working on is I wrote this code that'll solve these complicated looking equations and get like approximate solutions. And these equations describe like if you have like 2 chemicals just kind of like hanging out somewhere, how they react with each other and move around. Just died like 5 times. No worries. New Year or happy New Year's to you too. I appreciate the raid. And so yeah, depending on your initial conditions with that equation, you get cool looking stuff like this if you actually like graph it out. I don't know if it's in Python by default, but with NumPy for sure, the @ operator is matrix multiplication. So yeah, that's doing matrix multiplication there. Just star is like element wise. So yeah, I'm gonna make a copy of this code because this is homework that I wrote or that I turned in a few weeks ago for one of my classes, and I want to change it around a bit. Wait, what did I call my other file? Vortex. Okay, let's keep the same naming convention. Reaction, diffusion, simulation. Recommenders all submitted the recommendations early. It's you, it's cramming. I'm glad that they're not, or at least that they're apparently not annoyed by the number of schools that you applied to, which is good. I'm glad to hear that. The most recent time I applied, it was the reverse. I had all my applications done like weeks in advance, but I had to hound one of my recommenders in particular. And then a different one just never followed through, which really like fucked with me. What am I doing? I guess I wonder if this code for the animation is slightly off, because no, how do I zoom out? I would like to zoom out now, please. What? No. How do you zoom out? Shift click? No? Control click? Oh, control click. Okay. It looks like there's like a different image. Like the corners look weird. They're not quite square. Merkers are the movements just I applied to Yale and Brown, so he had 2 more applications to do. That does not happen with the other solution. I don't know what could possibly be wrong with this, though. Because it's the same code, basically. I don't know. If you don't get an offer from at least one of them, I'm going to blame that recommender. Perfect. I love it. Can get rid of those. Oh wait, no we can't. Not yet. Okay. What am I doing? What am I doing? What am I doing? Oh God. You know what? We are getting rid of these. Well, what am I doing? This, oh my God, I really hate the way they made us do this homework too. This code is, it's not even my code. One of the TAs gave this code to me. because it's one of the many ways that this homework was really arbitrary and they didn't tell you exactly how they wanted it in the assignment itself. um you know, okay, before we get too crazy with this, I think I want to run the same code for more time steps. Because I just want to see how it behaves for like longer amounts of time. You only did like 9 time steps for the homework. Excuse me? $147? Oil the mods up? I'm on it, Eldritch. Hope you're doing well. Oh, you know, I probably never updated my code. I probably didn't update this code after I updated this code from what the TA gave me. What a great year to waste. Yeah, I don't really care about New Year's personally. I don't really care about much any holiday. Why did I start a mastery, man? I feel like I can't even think about this code right now. 25 is empty. Hope they patch World 2026 Alpha. Hopefully. Earth could kind of use a patch. For sure. Another space DLC? That would be awesome. Okay, so I want to get rid of all of this code, basically. And I want to get rid of this. But I want to make sure that when I do it right. When new updates come around, there are always glitches. That's true too, Papa Dory. Yeah. Because I think this code feels really needless to me, the way that it's written. Like this is vector-based programming. We're allergic to for loops here. So Sol FFT, what is that giving me? This variable here, it stores Winklebot, thanks for the follow. Flashbang out, by the way. Sol FFT is giving me a vector. The first quarter of it is the real part of U. The second quarter is the imaginary part of U in Fourier space. The third quarter is the real part of V. The last quarter is the imaginary part of V. And I need to split that up and put them back into a matrix. That's what this code does, but I think I can do it better. That's why I'm doing this. Actually, oh, awesome, Winklebot. Yeah, welcome in. Yeah, so just for like a bit of background about me, I'm a graduate student studying for a master's in applied math. Oh, nice, Mistral. Good luck. And so yeah, I've been doing these math streams for nearly 3 years. Next month it'll be 3 years. But yeah, this is a really awesome thing. And in case you're not already aware, I'm actually not the only math streamer out there. All right, this list is kind of long. It's always getting longer, but there's a whole little niche of us who do math themed streams. Femistral does like math study streams, and Zach or Eats a 2i Pie just popped in too. He also does math streams. And so yeah, Zach, happy New Year's Eve to you too. I hope that your break has been good. Right now we're doing I'm trying to clean up some code that I wrote over the quarter for Reaction-diffusion. And so as part of the homework, we got solutions that are like this cool like spiral thing. Bro, Zach is an AI that does math too, yeah. Returning student planning on a 4-year, hopefully master's in math. Nice! I was done with 2 years at community college. Calc 1 and 2 as independent study, pretty fun so far. That's amazing, yeah. Calculus is where I like fell in love with math, but before I took a calculus class, I did not like math. It sounds like that you liked math, but before that though. That's awesome, Winklebot. Like, best of luck on your journey. If there's anything that I can do for you, like, if there's any like questions you have, please do let me know. Either about math or like applying to schools or anything like that, or just in general. I'm not picky about like answering questions. Linux physics, you love math, but unfortunately math hates you. Can feel that way sometimes. Just wanted to go to school for it. Took 12 years to get the ball rolling after high school. Oh, nice. That's gotta feel weird to go back to school. So I graduated when I was 21 with my undergrad in applied math, or bachelor's. And then now 7 years later at the age of 28, I'm going for my master's. And even at like, that's not that big of an age difference from the other people in my classes, but I still feel like the old man kinda, so it must be worse for you. But hey, better late than never. It's great that you're pursuing that. Is it worth it for you to get a 3-second GIF animation after 100 plus lines of code? Yeah, Desson. I think this is sick. I love seeing this. And plus, it's really easy to change this code for different initial conditions. Like I can just go. Is this the wrong one? No, it's the right one. I can just go, okay, m equals 2. Run. 1 minute. The suspense is building. Oh. Wait. Okay, never mind. It's not that easy apparently. Why is that? It does look different, but not that. Okay, never mind. I don't know why that didn't do that, what I thought it would. Oh, because I commented this code out like a dummy. It never actually saved the solution. Bruh. Math loves me, but my brain does not love learning. ADHD, that'll do it. An old man with a decade being out of academia, it's been pretty rough at the start, I bet. I thankfully I like I only just started on my master's in August of this year. So I had been doing the stream for 2.5 years, and that was basically how I remembered all the math that I had forgotten. Oh, come on. It's just toying with me now. Wait, no, it's down here. Yeah, look at that. Isn't that awesome? Okay, I finally got it. It's a 2-arm spiral now. Okay, that's not right. That one's not right. Oh, it's because my I remember that there's an issue with my animation with my code for this. Run stream ends. Yeah. Zach has done that, yeah. There's a nice ebook on ODs with interactive animations, but I can't remember the name. We learned about it from a Cedric Villani talk. Oh yeah, and sorry, I missed your other comment. I found any interesting properties of 2026 already. No, other than I feel like 13 should go into 2026, but it probably doesn't. If it does, that would be amazing. Sounds good, Winklebot. Look forward to seeing you again. Two times 10, 13. True. Secret trying to hypnotize us. Also true. 13. There we go. Oh yeah, Obi-Wan Pez is another streamer, but on his other account, and Simplex Pachinko. Nice ebook on ODs with interactive animations. Can't remember the name. Let's see. There's a really cool site for PDEs and interactive visualizations that FizzBuzz showed me. What is it, Mod 13? Oh, that's a good question. See ya. Dark overleaf? Nice. The dark overleaf. Ebook with embedded interactive digital elements. That's kind of cool. I like that. But let me dig up the site that FizzBuzz linked me to. Yeah, here it is. Didn't take much digging. visualpde.com. They have so many visualizations. It is crazy. Like any PD you can think of is probably listed on this. And so if we take like Turing on Turing, Turing patterns in Turing's image. Let's see what this one is. Well, what's the PDEs? I'm confused. I think this is like some type of Turing pattern using Turing initial condition. I don't recognize these equations. It actually could be a different reaction diffusion. Maybe. than the one that I was doing. I don't think it's not. Navier-Stokes doesn't have the squared, I don't think. Well, actually, these should be like partial derivatives. I don't know. Wait, so like I know my only intuition for PDEs is that the Laplacians are always like diffusion terms. So it's simply like something diffusion. Schnackenberg? It is reaction diffusion, which forms Turing patterns. No, it's a Turing pattern. Oh my, Wikipedia, please stop. Every time the last few weeks. How patterns in nature, such as stripes and spots, can arise naturally and autonomously from a homogeneous, uniform state. Pattern arises due to Turing instability, which in turn arises due to interplay between differential diffusion of chemical species and chemical reaction. The instability mechanism is surprising because a pure diffusion, such as molecular diffusion, would be expected to have a stabilizing influence on the system, i.e. complete mixing. I feel like they didn't really tell me what... Well, I mean, I guess they did. A giant pufferfish? Well, I want to see the pufferfish. Sorry, that's just a... That's a really weird picture. Like, I want to send this picture to someone with no explanation and just see how they react. I don't know who would be a good target. I want to see it puffed up, though. I want to see it puffing. Okay, I don't know. Okay, anyway. Digression aside. Let me put my code back how it was. M equals 1. Comment this out. Comment that out. Okay, this is the code that I want to change. So changing it back manually is harder and more error prone, so that's why I prefer to do it. I don't know. Yeah, you make a good point, Linux physics. I just don't do things the easy way. You know, we're just gonna comment this out. Let's go about this. I mean, this isn't the complete mainly way of doing this. The real mainly way of doing this would be deleting things instead of commenting them out. Okay, so Sol FFT is gonna be, it's gonna have it's gonna have a column for each time step. And so I need to take that column and divide it up into 4 pieces. Sol FFT shape 1 is the number of columns. So I want shape 0 for the number of rows. And then U is going to be oh god. Sol FFT. Sol FFT. It'll be now. Okay, we want the ith column. Everything, the first quarter. Ith column, this from S over 4 to S over 2 for the second quarter. Okay. Sol FFT. Bam. From S over 2 to 3 times S over 2 for the third. No, 4. Yes. Sol FFT. Ith column. And this will be from the third quarter onward. Colon. Okay. Theoretically, that'll work. Question mark. I don't think this line is necessary. Okay, delete that. What? Uncomment this. Okay, so get rid of you. Well, I'm going to change you into something else. S equals sol cheb dot shape 0. Just keep things consistent with how we did the other one. So wait, what is... Okay, sol cheb is something else, though. Sol cheb, we don't have the real and imaginary parts. So the first half of sol cheb is all of the u. The second half is all of the v. I guess that's all we need. Nope. Yes. Wait, that should just be S. Is that good? I think we might be Gucci. Let's run it and see what... Actually, wait. I increased the time step. Let me put the time step back down so it runs faster. Wah, wah. Oh my... I always forget to do this. Sol FFT dot y dot shape. I always forget my dot y's. It's not very wise of me to forget my dot y's. Dot y, dot y, dot y. And remember, the files are going to go down here. It already ran? Oh, nice. Looking good. Looking good. Okay. We actually did something. Let's delete all that. Below code. This function isn't mine. And I feel like if I'm gonna post this to GitHub, I should give credit where credit is due. But where is credit due? Uh, 254. Nope. Wait. It was somewhere in here. I remember it. I remember seeing it. You can't hide from me. Do I need to scroll further down, maybe? I think it is further down. Yeah, this is what I wanted. So this is MATLAB code. So the reason I'm a little weirded out by I don't know what to say about this because then like the professor, one of the TAs modified this code to work in Python. Okay, let me just record the page numbers. Page 266 to 267 of my god, bro. Bruh. Data-driven modeling and scientific computation. By J. Nathan Coots. Code, below method isn't mine. MATLAB code. Provided in. Modified, maybe translated. I think that's good enough. We could say one more thing. We could actually discover what the code does. For a given number of points n, this method returns the points in the domain, domain and a derivative, wait, points in the domain x and a derivative operator d for Chebyshev polynomials. Hey, $5. Oh, I guess I'll wait until the obligatory advertisement is over. All right, now hello, Fembox. Thank you for dealing with the ad. Hope you're doing well. Page 2. Okay, so I think this code is kind of fine. We just need to figure out like, or actually, I guess I want to see m equals 2. Oh wait, no. M equals 1, but longer time first. Now I just want to play around with the parameters and see what kind of visualizations we get. Because I never actually did it, but this assignment does say that this system can become unstable and chaotic. And that'd be kind of cool to find. I don't know which one we should touch for that. I guess beta. I did, but I'll say it again. I'm in advanced methods for ODEs. I'm in mathematical analysis in biology. And I am in scientific computing with data. So the last two classes sound kind of similar to what I've already been doing. Whoa. What's happening at the boundaries? I think we need to go for even longer time. What if we go for 60? It's your kind of schedule? Hell yeah. But yeah, so that ODEs class is going to be the next PhD level class. Because it's like a core of 3 classes that you can take at the master or PhD level, like, and it's 1 per quarter. And so this time I won't have the advantage of having like spent a summer studying ahead. And then the third one will be the PDEs class. So we'll see how that one goes. That won't be for next, or for like the quarter after this coming one though. Yeah, I wouldn't have minded taking like a different type of class, but there wasn't really that many classes that they offered, I felt like. So there was one class I was interested in about stochastic processes that I would have liked to take, but it has a prerequisite for a class I should have taken last quarter if I was going to do that, but I didn't really have room in my schedule to do that, even if I wanted to. I am back in Washington, yeah. I flew back on Saturday. Is this code gonna run, or is it gonna like finish at any point? What major? Going for a master's in applied math. Thank you, thank you. Ooh, oh, hey, cool. Now we're getting some cool bit behavior. Whoa, it's like it's zooming in and out. I think we need to go for even longer. This is really trippy. I want to go for 120. So yeah, I don't know if I'm gonna like get to it this stream, but I think I figured out a book that at least has been used for this ODs class in the past. I don't know if it's going to be used again. I meant to kind of go through this over the break, but I just haven't really had the inclination to actually do it. Hypno stream, exactly, Stooky. Hope you're doing well. Yeah, there's gonna be like asymptotic analysis of integrals. Let me just find it. That's somewhat where I hate it when the menu. This. So asymptotic expansions. You have a book on that? Ooh, I mean, if you like it, what's the title? I was going with this one because it at least has been used in the past for this class. I don't. It's super weird to me, but as far as I know, UW doesn't have like they don't post the syllabi for past classes anywhere, and it's really annoying. Like for my undergrad in Hawaii, there was like they had a website or like a part of their website you can just enter in the name for a class and you can see all the past syllabi for every time that class has been taught, and it was really nice if I wanted to like get ahead and figure out what a class is like, but there's nothing like that for UW, and it's so annoying. I just nothing like that I've been able to find. Yeah, and I feel like that's unfortunate. We use what do we use? Canvas. Yeah. My code for Reaction-diffusion is still running. And it's even more actually, and even for the classes that I am currently in, I don't have a nice clean syllabus to download for all of them because it's split across different pages or something. And so if I ever need to like apply somewhere else in the future and they ask for the syllabus for the class, it's going to be kind of weird. And if I didn't make sure to save it when I'm in the class, I would probably just lose access to it. And I guess I could email the professor always, but that's still annoying. Mark H. Holmes' Introduction to Perturbation Methods. Okay. Thank you, thank you. I'm going to put that into a browser tab, hit enter, and look for it later. Oh, really? So like I did do like a printed PDF of the pages on Canvas, and they came out okay, but it's still like, I don't know. Like I don't get why it's not customary to just put a PDF up there. Like I feel like I shouldn't have to ask. Yeah, you're right. Maybe I should just send those emails out. Make sure I have them. I mean, I'm not sure why you would need to lock behind a login wall, but like even my college in Hawaii, I'm pretty sure they were login walled. Were they? I guess I could try it now. And actually, I used to have this list in my about section, where I went. Syllabus. Let's see. Oh no, yeah, you can just do it. You don't even need to log in. I don't get why you would hide it. But like it's such a like it's not a very fancy looking site, but it's literally everything you could ever want. I think, is this the course code for differential equations? Let's find out if I remember it right. Oh, I think this is. Oh, it's discrete math. Never mind. I was scarred by that class. They're login walled. Is it the type of thing where like the university owns your syllabus? So like, I mean, I don't know if you could, if they could prevent you from posting it yourself on your own site. You own your stuff. Okay. Um, the code for Reaction-diffusion is still running. Oh, it just ran. Okay. Let's see. Yeah, Milk, we shouldn't have to, I feel like. Like, why hide it? You could, but yeah, that's fair, Zach. It's something that the university should do. Huh. About the Chebyshev. Ooh. Zone Ranger. Thank you for the prime. I really appreciate it. That alert kind of jump scared me. I was too busy hypnotizing myself. Hope you're doing well. This new film is trying to find resources. That's another good reason to have syllabi posted. I don't know. I should just ask like classmates. I guess if there's something that I'm missing here, because like it just seems like such a natural thing to provide, and yet it's not. Okay, so I apparently the system can become unstable for certain choices of parameters. So let's try making beta 10 and seeing what happens. Maybe we'll push the time down to 30. So now we have to write your own syllabus, class notes, and homeworks. I bet that sounds terrible. Utah Bill requires certain syllabi to be public now, which is sort of cool, but not all syllabi. Really? Is it only for like universities funded by the state? That's kind of interesting that they're actually, yeah, okay. But it's still like that's surprising that they're even like legislating about that. And also for required classes. not elective. Huh. I mean, I guess that sounds like a good idea because I've just been ranting about universities should be posting their syllabi. Distinction is weird. I don't know why. They whoa. What? This is so sick. I think we found some instabilities. That spiral is zooming. Huh. Okay, okay. Let's try 5. Oh yeah, Joseph, I'm going to a public uni and the syllabi are not public. You're a nerd, FA. No, you're not. You're nerd about Taylor Swift. Oh, that's a good question, Milk. Analytic instability. I'm not trying to get numerical instability. Those aren't good. This is the holy grail of cosmology. It started as spiral arms, then evolved into a big mess. Oh, that's funny. Okay, let's see how this looks. Oh, that's so cool, dude. Ah, I love this stuff. The Chebyshev is just a big mess. Like this one, I don't know. It just looks like soup. The other one, though, maybe it needs more points. It is. It's only using like half. It has like half the resolution of the other one. Um, let's try 61. I don't know how long it's gonna take to run, but let's try it. Are we seeing aliasing? Maybe? I wouldn't know. SCU syllabi are public. Just the large flagships in large states. SCU? The SCU I'm thinking of is definitely not the one that you're talking about. I'm not sure what that SCU is. Frames low-key look at the defect formation energies I was working on last year. I'm not sure what that is either. State call. Oh, okay. I was thinking like South Carolina or something. Resolution is too low. High frequencies end up looking like low. Oh, really? Maybe. Either way, we're increasing the resolution, so we'll hopefully get something more interesting looking. Also, this is maxing out my CPU. I hope the stream is still coming through okay. I did see momentarily in my OBS that the encoder was overloaded, but it seems okay right now at least. I have too many files. I need to get rid of these files. I also should have put some print statements in here because this might take forever to run. Oh well. What else can I rant about? What else is in this one ODE book? Um, Theory of Asymptotic Power series. Like, I guess this is probably what we'd be starting with chapter 3. Spontaneous singularities. It's like a more fun type of singularity. Oh, that's kind of cool. Asymptotic behavior of the gamma function as x goes to infinity obtained from the difference equations gamma of x plus 1 equals x gamma of x. Okay, perturbation methods. Still running. Let's just kind of look at chapter 3. 61. I'm going to guess it's 69. Even farther. Ooh. There we go. Wait. Is there King Arthur? Oh, Sir Arthur. Never mind. Wait, Sherlock Holmes. My mind rebels at stagnation. Give me problems, give me work, give me the most abstruse cryptogram or the most intricate analysis, and I am in my own proper atmosphere. Ooh, that's a nice one. The way each section is subtitled like a Victorian era tract. Wait, like in table of contents? Oh yeah. This is nice. I appreciate this. And so I want to say I learned about this as an undergrad. Which is looking at singular points of nonlinear systems of equations. And they're like locally linear around those singular points. And so you can get solutions around those singular points and then kind of just by intuition connect those solutions together visually. You will be pleased to know that after reading this chapter, you'll be able to write this nifty result on the back of a postage stamp. That's a bold claim. I don't know if I could even write the differential equation itself on the back of a postage stamp. Maybe that's my own lack of skill. Can this code complete yet? I'm I feel like maybe I'm pushing my luck with 61 points. Maybe let's try... 46, why not? Hey, Vasan. Hope you're doing well. Doing okay? Well, that's okay. The absolute value of x is nowhere analytic? Why is that? This is for complex x, I guess. I'm doing good. Thanks for asking. I almost kind of regretted doing math today because I don't feel that mathy, but I'm still making progress. I feel like this should be a really simple statement for me to understand in this part C, like bullet point. But why is that not analytic anywhere? It's only not differentiable at the origin, right? Okay, when in doubt, Koshi Riemann. That's not the right window. Where's my pen? So the question is basically, is this function analytic? And so if we want to know that, we should look at, oh man, do I have this memorized? U sub x equals v sub y? Oh, maybe I see the issue now. Are these the Cauchy-Riemann? I forget where the minus sign goes. Googling it. Ux vy uy minus vx. Okay, yes. We're Gucci. New Year's in 30 minutes here. I don't blame you. I don't think New Year's is that worth staying up for. There's something weird in my mouth somehow. That's what she said. I'm gonna spit it out. I think a mustache hair somehow got in my mouth. It was really like unpleasant. And yes, you guys needed to know that information. Okay, so the issue with Cauchy-Riemann is that this is our u function and 0 is our v function. And the only point where the Cauchy-Riemann equations are satisfied then is at, well, probably at, okay, well, let's at least take these derivatives, but it's probably only going to be at the origin. Maybe not even at the origin. Either way, it's going to mean it's not analytic, but... Oh yeah, this isn't a bad song at all. I haven't been paying attention. This is Awake by Tycho? Okay, so the Cauchy-Riemann equations... Oh no, okay, so it's not even valid at the origin. These are undefined at the origin. I was gonna say like x and y have to both be 0, but then we get 0 denominators, so... Okay, I now understand why this function is nowhere analytic. Probably should have been able to figure that out mentally, but here we are. Has my code run yet, by the way? Oh, it has. Ooh, this is much better. Oh, that's cool. Yeah, I think we just needed more points. Rest has a peaceful effect on your physical and emotional health. Hey, okay, that's true. And hi, Rex. Okay, okay, this is good. Let me put beta all the way down to 2. I want to see if I can... I don't know what I want to see, but I just want to see. Christmas card design for next year? Oh, that'd be such a nerdy Christmas card. That sounds amazing. You know, I forgot to do it. I meant to link my Spotify to my Discord profile. So that way people want to see what song's playing, they can just look at my Discord. I need to remember to actually do that. Do it. That would be like an electronic Christmas card or something in order to be in animation. Okay, I guess we'll go back to looking at the book while we wait for that code to run. How do you pronounce this Fuchs? Because I want to say fucks, but it's probably Fuchs. To the photon, it is created and absorbed at the same place at the same time. I did watch that video that you posted. And my feeling on it was that it feels like a leap to make a limiting argument with the speed of light. I don't know. I feel like I didn't quite buy it. The dude might have been right. But for those who didn't see, Rex in the Discord posted a video where the question is basically, if you were traveling at the speed of light, would you experience time? And he was talking about the gamma, which is the Lorentz coefficient, and that is 1 over root 1 minus your velocity that you're traveling at, v, over c squared. But if you're traveling at the speed of light, then this is also c. 1 over root 1 minus 1, which is 1 over 0. And so to deal with that, he instead made a limiting argument with v approaching c. And he used that to make the claim that well, yeah, that's the point. It's undefined. Like, we can't say it's anything. Hey, Kodkio, Happy New Year. He made the argument that as V approaches C, I guess from the left. Or from I don't know. But basically that if you're trying the speed of light using limits, you can say that you don't experience time at all. But I feel like that's kind of abusing special relativity. That's at least what my gut is telling me. I don't know that much about physics, but I don't know. That's one where I'd want to ask someone who actually knows more about physics than I do, because I don't know. The stuff he was saying seems a little I don't know, maybe just incorrect. Oh, it depends on, okay. I kind of want to hear like all of these, but we'll start with there's 2 USA pronunciations. Fuchs? What is that voice? Kirk? My New Year's in 20 minutes. Hell yeah, Kirk. Happy New Year. Thank you for the 15 streak, Rex. Doesn't change anything but the derivative. Oh, yeah, this over here on the left was for a different thing. Like these two things are separate ideas. I don't know if you're saying that for a different reason though. You love getting women's menstruation ads while coming to see the dawn. Hey Tyler, I've been getting diaper ads, and it's a really creepy one. Fuchs? Okay. How about UK? Also, hey, Broral. I don't know if anyone else was the same, but I really dislike text-to-speech voices. This is not helping. Hey, wait, that one was Fox. Fox? I don't know. That doesn't... What the hell? That's just mumbling. You know, I don't know, Burl. Be more on target. All right, well that was a journey, I guess. There's even more. I'm not going through all these. Oh my god. Okay, yeah, I'm not going through all those. Did my code run? Oh, hey, it ran. What? Oh, yeah, this one was beta equals 2. Okay, what kind of hypnotizing did we get this time? Ooh. Ooh. Okay, this... Oh, it needs to go for longer. But this might be my favorite one. Oh my... Yeah, this needs to go for longer. This is my favorite one. Let's go for 60. Oh, should we go for even longer? Let's go for 90. Uh, oh yeah, Kirk, hit me with it. Uh, code. Yeah, this is code that, code Keo. This is code that I wrote for a homework assignment, like last month. It's getting the solution to the reaction diffusion. Well, one of the reaction diffusion partial differential equations. There's many of them. And so this can represent like if you have two different chemicals just kind of hanging out somewhere, how they both move around and react with each other. It's Fuchs from the German for fox, where you pronounce the U like the oo from zoo. Okay. Fuchs. Keo. Okay. Sounds good. Yes, it's from a class. This was a homework assignment that I'm kind of cleaning up so I can post it onto GitHub. Y prime plus y squared equals 1 without that one hyperbolic tangent identity. I don't know what that one would be, but... Um... Well, this is separable, isn't it? Like, that's just arctangent, right? Is that our arctangent? Or is that 1 plus? Oh my god, why don't I know this? Uh, I feel like this is embarrassing to not just know that. Arctan X prime. I'm going to Wolfram Alpha right now. Okay, no, that's not arctan. Do you just, oh, you just, that's just partial fractions, I guess. It's LNs. Yeah. I think this is, hmm. Is this minus sign? No, I don't think it will. I think that it's gonna be 1/2 and 1/2. I guess the negative signs, I don't know, but let's just do it the long way. A minus B, A equals 0. A plus B equals 1, so A equals B equals 1/2. It is 1/2, 1/2. Okay. And then, I guess we'll do e to the power of each side from here. Is that the best idea? I guess it doesn't matter. Uh, and I guess we square each side. Do we have to quadratic formula this if we want to isolate y? Oh wait, no we don't. Ha. Forgot about that. So y squared is 1 minus c e to the 2x. So y is plus or minus root 1 minus c e to the 2x. And I think we might need to check that both the plus and minus satisfy the original differential equation. Lucas, 12 minutes for you. Nice. Hope you have a good 2026 also. And yeah, sorry, Kirk, I kind of flew through this without really explaining myself. Yes, sorry. Let me back up there. Okay, so I was debating the took me a second to work through my head. I think maybe the easiest way to see it is to use log identities to bring this in as an exponent inside there. Oh, redo. What am I writing? This is very sloppy. Absolute values in ones, my absolute values in ones look the same, so sorry. Very sloppy handwriting here. And then we can use log identities on these two to make them into a product. And so I just kind of dropped the absolute values without really caring. I should make my ones like that. And now from here, I did e to the power of each side. Like that. And so hopefully that clears it up. I didn't really do a good job of explaining that part of it. I guess I took away the absolute values in the next step when I squared each side. You get it more now? Okay. Yeah, so it's better to just use log identities first and then do e to the power of each side. But yeah, and then from there, squared each side, and I dropped the absolute values. I don't know if that's really the most valid thing, but I don't know. I feel like you don't really care that much when you're doing differential equations. The left side becomes 1 minus y squared if you multiply it out. On the right, the 2 gets multiplied into each of the exponents. So it's e to the 2x plus 2c. But again, in differential equations, like 2 times c, we don't really care about it. It's still just a constant. So I just rewrite it as just c because it's still just a constant. It's not going to make a difference to multiply it by 2. And further with that constant, we could write it like e to the 2x times e to the c using exponent identities. And then e to the c is a constant to the power of a constant. So again, who really cares about it? Just make it a different constant. You make a fantastic point, Kirk. It absolutely is. I made a mistake. Thank you. So we actually have oh my god. Bruh. It's all wrong. So it's going to be division. It'll be this divided by that. And then we get I guess you could keep the exponents outside if you want. We could factor them out. I was thinking I brought them inside because of the doing e to the power of each side step. That one's a little bit more weird with the 1/2 in front, but still like not a big deal. I guess, oh, just multiply the 1/2 to the other side. Sorry, that's way easier. And now do e to the power of each side. There we go. Yeah, that's a lot easier. You're going now? Okay. For New Year's? Okay. Enjoy whatever your New Year's plans are. Thank you for the question. I think we've at least done the hard part of the question. This is just kind of doing some algebra and moving things around now. Can we even isolate y here? I don't know. Either way, enjoy. Let me just see what Wolfram Alpha says the answer is. Out of curiosity. Wait, is my code still running, by the way? It is. Oh my god, Joseph. So many applications. Oh, it's Riccati's equation? You swear to your cow? Oh, yeah, that is some type of hyperbolic tangent. Pre-algebra review? Okay. Okay, I was thinking that Riccati's equation, I think, is more general. And it is. Ooh, there's a trick here? whenever Q2 is non-zero and differentiable. Q2 is -1, so that's certainly not 0, and it's certainly differentiable. Make the substitution v equals yq2. Well, let's just take that step and see where it gets us. So we're gonna make the substitution v equals -y. That's what they're telling us. Yeah. Which means v prime equals -y prime. Well, how is this helpful? We get -v prime equals 1 minus v squared. This isn't second order. Satisfies another Riccati equation. Oh, then you do a second substitution. What the hell? Equals -u prime over u. Who thought of this? Probably Riccati. Hey, Anakin Luke. Apparently, he does have a cow. I'm not required to take any computer science classes. We are expected to have a baseline knowledge of Python. We don't have any dedicated computer science classes that we have to take. We do have classes about programming though, but it's programming in the math context. So sort of, but and so and actually even then I'm only required to take one programming class also. I could theoretically try to avoid classes with programming. Actually, from now on, since I already took that one required class. But I enjoy it, so. Oh, my code ran. Let's see, let's see, let's see. Ah, dude, that's so cool. That's so cool. This is the coolest one. Yeah. Oh, no worries, Kyo. How about the other one? Okay, yeah. The first one is definitely my favorite that I've made today, but this one is also pretty cool. Okay, I want to keep these. I guess, yeah, unstable. Okay, I want to try with m equals 2. Yeah, and then everything else we'll keep the same. So what's up with this substitution? Negative u prime over u. Does that follow, though? Let's try. Well, first let's clean this up. So substitution v equals minus u prime over u, it was? Yes. So that means we need to figure out what v prime is. I guess that's a quotient rule. Resident sleeper. High d low minus low d high over low squared. Well, that's just stupid now, isn't it? So does this clean up if we sub this in? We can get rid of the denominator. U double prime minus u prime squared. U prime squared minus u squared. Well, wait. That's not good. This isn't linear. I must have done something wrong. V prime minus u double prime over u squared. So wait, they were doing more work on this. They noticed that this chunk here is v squared. It's negative v squared, isn't it? What the hell? The helly? I have a sign flipped here, I think. It's gonna bother me. Okay, so this minus sign stays out front. Low D high. Wait, high or low D high minus high D low? God, I can't remember it now. I hate the quotient rule. We're doing product rule. The minus stays out front. You're gonna think of it as minus u prime 1 over u. So we get u double prime 1 over u minus u prime 1 over u squared. Squared. Oh, chain rule. U prime. There we go. Maybe? Yeah. So this bit here is v squared. Okay. So mu. So then this v prime is v squared minus that. That v squared is, well, we just keep it as v squared because they're going to cancel. Okay, so those two cancel. We're going to get u double prime equals u. And that, my friends, is in exponentials. C1 e to the x plus C2 e to the minus x. Yeah. But that's not the exact thing. Okay, so this is u, but we need y. So we need to go back through these subs. So we need to get v. I don't know why I'm talking about this inflection. So u prime is c1 e to the x minus c2 e to the minus x over u c1 e to the x plus c2 e to the minus x. And then v is negative y. So y is c2 e to the minus x minus c1 e to the x over c1 e to the x plus c2 e to the minus x. I guess that's the answer? Not happy about it. What? Wolfram said something slightly different though, didn't it? Oh, this might. I don't understand why there's constants in the exponent. Maybe that's probably not a big deal. I think it's just Wolfram Alpha being weird, maybe. But Wolfram Alpha, I think, did one of these bad boys. And then these two constants, you could write them as e to the c2 if you really cared to. Wait, I'm off by a sign, I think. Or maybe they Were they tricky with their constants? They might have done a trick with the constants. I think they did one of these bad boys to make it C2 over C1 minus e to the 2x e to the 2x plus C2 over C1. And then these are just new constants, I guess. I still don't know, like, they have these two things reversed, though. I'm not sure why. I was wondering if it was something in this step, but I don't know. My code is still running. Kirk. Oh, I thought that you were, like, gone for the, that you'd be gone for the rest of the day. I was still playing around with your equation. So I plugged it into Wolfram Alpha. And it called it Riccati's equation. And so I looked up Riccati's equation, and it's more general than just the one that we're looking at. But Wikipedia gives a nifty way of solving them, where you do two different substitutions. There's a typo here. Why is that S capitalized? Anyway. First you do substitution, v equals y times whatever this function is. For us, it's -1. So I did... Oh yeah, this kind of... I went down a rabbit hole. But yeah, so first you take v equals to minus y. That means v prime equals minus y prime. So taking these two facts and plugging them in here, you end up with v prime equals v squared minus 1. And then you do this other substitution, v equals minus u prime over u. And if you do enough algebra work, you get this really simple second order equation, u double prime equals u. And so I've solved enough differential equations that I can just do that by sight. The answer to that one is u equals c1 e to the x plus c2 e to the minus x. And then the only thing that remains after doing this is to go back through the substitutions and undo them to get in terms of y again. So I got v, that v there, by taking this u and plugging it in here. Thank God you got to call me a nerd a second time, F.A. Shouldn't you be out having fun, partying, or something? Having a life? And then once I got this v, I used that equation to find y. So it's just a negative sign. So I got that as my answer. Which, that is good enough for me. But Wolfram Alpha did something a little bit weird. I mean, not necessarily weird, but they kind of like try to clean it up a bit. I don't know if this is cleaner or not, but you can kind of get rid of one of these constants. So maybe I'll call it C3. C3PO. You have cheesecake at 1 a.m.? Oh, I love cheesecake. Just took a dive in the ocean. I'm the happiest I've ever been. Damn. All right. Look at you having fun. All right. Sounds good, FA. Enjoy the lurk. Enjoy the ocean too, I guess. Ocean woman. Now there's a thing where Wolfram Alpha, they have the sign of that flipped. A CO blob, whatever that is. Okay. I feel like I did everything right though. So I wonder if I just did something weird. And I kind of want to take my solution and plug it into the differential equation to test it. As much of a pain as that's going to be. I'm going to do it. So we need to find y prime. That's going to be a quotient rule. Low D high. Low D high. Low D high. Okay, low D high minus high D low over low squared. Is this? Yeah, I guess that's right. E to the 4x minus 2c3 e to the 2x minus 2c3 e to the 2x. What did I do? Plus 2e to the 4x over e to the 2x plus c3 squared. And these two bad boys cancel. You love to see it. Minus 4c3 e to the 2x e to the 2x plus c3 squared. And so does this equal 1 minus this squared? That's going to be a pain. One minus c3 e to the 2x e to the 2x plus c3 squared. I don't know why I normally don't like doing this much algebra, but today I guess I'm just in the mood to algebra it up. Do I have a shortcut here if I work on that one first? Maybe. So if we take this one and get a common denominator, we end up with this. And I was hoping to... Oh, no, there's no shortcut. We just have to do math. Resident sleeper. No, this does match though. I'm just doing this mentally. Wait. I hate doing math during my math stream. You're completely correct, Kirk. This is not a place for math. I am off by a sign. That is so annoying. There's a negative here and no negative here, so I did do something slightly wrong. No. Oh, wait, yes, it does. Oh, yeah, that's the trick I was hoping for. It is a difference of two squares. Um, I just multiplied each of these out individually in my head and then combined them together. That sounds harder than it is because mo most of the terms between these two things cancel, so you don't have to worry about them. But yeah, you could also difference of squares that. Where did I go wrong in this problem? I definitely have gone wrong in life, but I'm not asking about that right now. Look at the Wikipedia page. Actually, did my code run yet? Oh, it ran. 1 second. Oh, dude. That's another cool one. God damn it, these are so cool. Okay. Um Okay, I think I do want to change up the visualization a bit though, because I think I realized I don't need the two side by side. I'll do that in a minute though. Like we'll wrap up this the differential equation that Kirk asked about. Oh yeah, Riccati equation. So yeah, these apparently have a known way of solving them with all these different substitutions. So we have a Riccati equation where Q0 is 1, Q1 is 0, and Q2 is -1. Oh, there's just, you can jump straight to a general solution for that. Wow. I made a side mistake somewhere in my work, and it's gonna haunt my dreams. Guess I rid of my national math competition thing with a total point count of 32 out of 60. Hell yeah! Congratulations. What type of like math competition is it? Is it like an Olympiad, or is it like a I don't even know what all the different terms are, so like what types of problems is it, or like what level is it at? Hmm. You know the English way to explain it? That's fair. It's pretty general. There were induction proofs, primes and divisibility system equations, high school stuff. Okay, yes. That's awesome that you got through to the second round. The high school competition programs, sorry, the high school competition problems I can at least figure out most of them. Um, but after that, I just become completely clueless. The tricks become too vague, or like too difficult for me to figure out on the spot. Um, I'm still looking for the sign mistake. I really am not. Oh, I found it. I forgot to include this minus sign here needs to go right there, and I didn't do that. And then from the next substitution, there's another minus sign, so just going to cancel out with that minus sign, and so these should get swappy dude back. I think the problems for the current years is not public yet. Oh, okay, fair enough. Yeah, sure. Could be entertaining. I finally figured out this uh Riccati's equation, so I can sleep easy tonight. Okay, I'm not gonna go and redo this part, but or that part. But I'm now satisfied that I got the right answer. Oh, one of those. One over root 10 minus x minus 1 over root 10 plus x equals 2. Okay. What do we do with this? I'm gonna guess getting a common denominator is a good idea. Is it though? Oh, maybe. Should be their real conjugates. Yeah. My hope was that we could then multiply the denominator through and something magical will happen. This is a difference of two squares. Um, or maybe well, yeah, okay. I have a different idea, but I can get to it more directly. What if instead? No, I can't. Never mind. Um, Squaring each side, I don't think is a good idea, but we could multiply each side by that. Seems like it might do something. No, it doesn't. Uh, Conjugates. Yeah, I was about to write that's 100 squared minus x squared. I didn't think that was particularly helpful though. Or at least I didn't know how that's helpful. Hey Slim, will I fly a kite in 2026? Probably not. I haven't flown a kite since I was a kid. I'm not opposed to it though. There's plenty of wind here. OpenStack's pre-algebra is not too bad. Yeah, I haven't like looked at OpenStacks much for myself, but I think of them as like not bad. Um, it's got to be a trick here. Well, yeah, of course there is, but like, ugh. They have the kites that look like a box and basically fly themselves. Flying a kite could be a New Year's resolution. That's true. It could be. Would flying a kite bring me some like childhood joy that I've been missing? Why am I stuck on this? Should I just bite the bullet and square each side? All right, let's just see what happens if we square it. I was writing about a sub like that, but I couldn't mentally figure out how it would help. You're more like Charlie Brown with kites, never got to fly one, and now that I think about it, maybe that's where this hole in my soul stems from. You know, that's a valid point. What if all the problems that we have now as adults stem from our lack of flying kites, either at all for you or maybe flying kites often enough for me? Like that's just the source of all our problems. And if we just finally fly a kite, it would fix everything. Ooh, this should be plus. Mr. Banks. I don't know who that is. Jake? I don't know. Academy of Useful Ideas are slim. As if I would fly a kite in 2026 and you know, maybe it's gonna fill that hole in both of our souls if we do. You played a Winter Cherno yesterday, right, Jake? I hope that went well. Wait, Mary Poppins? Oh, is Mr. Banks from Mary Poppins? I don't remember that. BRB? Okay. There's a film called Saving Mr. Banks. I don't think that's it. The dad? Oh, interesting. That too? Oh, that's related? Oh, okay. Slim just sent me an example of the kite that he's talking about. I think I've seen these. I haven't seen anyone flying a kite in a really long time. They're both great films for different reasons. Interesting. I never heard of the Saving Mr. Banks one. I want to say I've seen this type of kite. I never used it. But what kite? I can almost remember the kite that I did have as a kid. I can't exactly remember it though. I remember the beach that I flew it at. I don't remember how it looked though. Because the world was getting worse. Coincidence? I don't think so. They're all flying drones now. That's what the kids are doing. Oh, yeah, okay. I'll leave it on that one. Let's go fly a drone doesn't sound the same to me. It doesn't sound the same to me either. And that's a shame. Do we square? Are we gonna square it a second time? That would be really funny. I don't think we are. Maybe we are. I don't know. Should I multiply this out? I feel like I should. I'm gonna multiply it out. 400 minus 80x minus 4x squared. We can bring the 20 over, multiply through by -1, divide by 2. Okay, can I do this all mentally? It's a dangerous game. So that, okay, subtract 20, that becomes 380. Divide by 2, That becomes 190. Can we factor this again? $95. What a dumb number. Who even likes 95? 95 is 5 times 19. Ugh. I think I'm gonna square this a second time. I don't see a way around it. I'm sure I'm not 6, 7. Oh my god. We should just express all numbers in terms of 67. That's the natural progression for math. 67 should become the new 0. I have to square that mentally? Well, I don't have to square it mentally, but I'm going to. X to the 4th. Plus 20x cubed minus 95x squared. Plus 20x cubed. Plus 400x squared. 20 times 95? Ugh. 190 times 10. 1900? Oh my god, Joseph. Yep. You should hibernate. That's a really stressful thing you've just gotten done. I hope your applications go well. $95 squared? Bruh. I'm not doing that on my head. 9025. Well, it's only 9025? I feel like it'd be more. For some reason. This is terrible. I'm not going to solve a quartic. Okay, where's our cubes at? 20, 40, 40. Squares. Minus 95 plus 4. Ooh. 305? Ugh. 210? Minus 3800x plus 9025. Terrible. Check that left side. What's wrong with the left side? Skirtle. A new romance is in the near future because I stole Jake. Yep. Just gotta accept what the future holds, Skirtle. Minus 10x plus 10x? Oh no. I made the same mistake earlier in the problem. This is all garbage. Thank you for catching that, Jed. Okay, I'll have to redo this. This is a for fun problem that Kirk's Logical gave us. It's a high school like competition math problem. Just solving that for X. Still in 25, I'm in 2026. We're not the same. That's true. You are in 2026. I did not stream my Twitch Wrapped. I could. Are those still available? Maybe a mental break wouldn't be a bad thing. Oh, yeah, it is still available. I looked at it. We can scroll through it, though. Aim to get good at math in 2026. Then you'll take over the universe? Hell yeah. Z Hurricane, good night to you, too. Thanks for being here. Wait, at least Calc 1? Hell yeah. It's a good goal. Yeah, hi, Floppy, by the way, if I didn't say that. But yeah. I kind of forget what was even on this thing. Please? I'm clicking. Click. 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 What? Do I just need to scroll down? Or... Oh, I get it. Okay. I'm just dumb. I thought it would bring me to a different page. That'll complete in a couple months. A few hours a day is fine, though. Yeah, just gotta, like, build towards it. High scores. You're doo-doo. I'm a graduate student. Z Hurricane. I'm going for a master's. 733 hours streamed. Not bad. Total streams, 179. Not bad. Distinct days streamed, 177. It's more than half the days in the year, right? No, it's just like, it's a little less than half, isn't it? Really? I guess because grad school, that's why. Okay, fine. Hours watched, 80-70. Number 3, I'll take it. Thank you. Top categories, unsurprisingly, math and DayZ. I already have a bachelor's, Femistral. I got my bachelor's like 7.5 years ago now, or something like that. I just started on a master's in August. Scientific technology must have been the general relativity stuff I was doing. Hollow Knight was a good time. Planetcraft was a good time. Apparently I didn't stream 6 things. Math number 1, exactly. Thinking of doing that for IT, it would cost too much. Yeah. It's expensive. Wait, what's old head? I don't know, but hi Fizzbuzz. Number 2, number 4, you don't watch anymore. Number 5 died? Oh no. That sucks. I did stream Repo and Sifu. Or maybe the goat was just there for decoration. I'm from America, Z Hurricane. I don't know. I just call You know what? You can call me old as much as you want, Fizzbuzz. You have a pass. Getting IT degree. Fair enough, Mistral. I think the goat's just there for decoration now that I think about it. But yeah, you're right, Skirtle. I did do Sifu and Repo, and probably did something else too that I just don't remember now. F and HC, thanks for the follow. You are finely aged, Zach, like a fine wine. Gonna go to academia soon. Hopefully, I'm wondering how I'm gonna handle my future skibbity Gen Alpha students. Godspeed, Floppy. Whippersnappers, the lot of you. My top stream reached 304 viewers. That must have been a raid from DayZ. English, educational, math. I wish they would say what stream it was, but it was definitely a DayZ stream. The hardest class for me personally, I think, was discrete math. during my bachelor degree. 300 math viewers, that would be a dream. 68,000 chats, not bad. Top channel emotes. Hey, what? The lightning bolt is kind of, I feel like it's one of my worst emotes. But fair enough. Hey, and one of Skrtles is up there. It's a good one. Oh, you know what? Part of this is from me. Like, I have whenever I get a raid, like certain, like my automated messages and stuff will use certain emotes. Oh well, thank you. I made that hey myself when I first became an affiliate, so I'll take it. What are the qualities for admission in MIT? You should look at their website. I don't know. 96 hours pen is 100. Nice. Biggest fans: Lucas, Petri, Jasu, Astro, Fish, Jed, Obi, Femvox, Harlock. Damn. Good people all around here. Heart throwing penguin. I do really like that emote. That was just one I bought off of Etsy. Well, thank you, Famistral. Crossovers. Numbers of stream togethers 8. Zach, Slim, Fizzbuzz. 216 raids received. That's kind of a ridiculous number. It is kind of boosted. Well, wasn't that boosted, but like Destin was definitely doing a bunch of like meme raids, but not that many. But I had 216 raids received versus 179 streams. That's more than one raid per stream, which is kind of crazy. And yeah, a bunch of them from Slim because our schedules just lined up really well. Sure, Z Hurricane, you can try me. Then it, from Zach, and then Change. I haven't talked to Change in a minute. Raid sent 149. Who did I raid? Yeah, it's really just a function of like the schedules, but Gold, Obi, Shane, that sounds about right. Let us make sure to raid you. Yeah, back when I had a schedule. That's true, Slim. Yeah, you could just raid me randomly. 39 clips made of me, 12 unique clippers. That's kind of like not quite accurate because if you do exclamation point clip, then I count as the clipper, but it could be from someone else. 500, that's a lot of followers. 39, that's a lot of subs. 11 hype trains, that's a lot. I did not raise $2,000 for charity. I would love to have raised $2,000 for charity. That just can't be right, though. How would I have raised that much money for charity? I did have a charity thing running for a few weeks, but that was like more like $30 or something, not $2,000. I have no clue what this one is from. Almost 600k channel points spent. Oh, from ads? I make almost nothing from ads though. Like it's only the pre-rolls. Unless Twitch is adding ads or something. I don't know. I have no clue where that is coming from. Well, no, the charities are rich, apparently. Twitch's income? That's, yeah, okay, that's fair enough. Tax extortion coming my way. Oh, and that's the end of it? All right. But yeah, not a bad year. I think the community thing, oh yeah, that's for like Twitch globally. Meh, who cares about that? Oh, wait, that's not what I wanted. I know. My viewer one is kind of messed up because I just have tabs open for people that I like. So I kind of I feel like these are like no life stats, but yeah, there's just a bunch of like DayZ streamers and then Obi in there too. And he's not a DayZ streamer, but yeah, a lot of chats. My top emotes. Oh hey, look at me, mod of the year, modding for one channel. Yeah, I don't know if this one is as interesting. Wait, my top viewed clip? Oh, that's the one where I broke Central's legs. That's a good top clip. I just want to rewatch it because this is a funny moment. I still don't know if I actually broke his leg. No, I did. I made him a splint. I didn't hear the leg crunch sound though. That was a funny one. You have 6081? Oh, sorry, Z Hurricane. I do just have you beat. Let me read your question. Alpha and beta are roots of that. Oh god. Yes, Z Hurricane, I'm sorry, that doesn't look like a question that I can do. That looks like a crazy one. Love some central leg breaking? I know. That was like a competition problem, Z Hurricane. And I'm not very good at those. Well, that's up on 24/7. Oh yeah, like yeah, Z Hurricane, it looks very hard to do. As long as I'm not like asleep, I have streams open for everyone who I like. And so it sometimes gets ridiculous where I have like 8 tabs open at once. But I don't know, I just like to support the people who I like. Number 1 is Iron Mouse. That does not surprise me, Skirtle. Four Twitch tabs. Nice. Yonetta, the lottery prize here will be 1 billion. Root for my dad and I'll donate some subs in retribution. Ooh, okay. I go Yonetta's dad. Yeah, win the lottery. Oh, how much is that in American dollar reduce? 1 billion BRL to USD. Wait. That's even more money. All right, see you, Z Hurricane. Sorry, I couldn't help with your question. Wait. No, 1 billion. Sorry, I don't know what billion is. I don't watch anyone else. Y'all suck. I don't blame you, Skirtle. I know you're just a hate watcher here. Okay, you know what? I'm not turning down 181 million. That's ridiculous. Hey, Doomwood. Distinct days visited 366. That's impressive, considering it wasn't a leap year. Hey, energy. Wait, was it not a leap year? It's divisible by... No, wait. Okay, yeah, no, duh, it wasn't. It's a humble 181 million. Yeah. It must be a weird thing with how they're counting it. I don't know. Oh, yeah, I don't have that set up, Famous Troll, but you can click on your name and see how long you've been following. You've been following since December 1st, 2024. See Hurricane X equals 1? 480 hours watched, 4,000 chats sent. Damn. Well, thank you. Yeah, what's the question, Doomwood? My Earthworm Penguin's top 5 emote list? Hell yeah. This problem is way simpler when I don't make a mistake. Okay, now we square each side. $380 times 2, what is that? 760. $190 squared? 36,100. Oh, hell yeah, Yonetta, thank you. Oh, what a stupid quadratic to solve. I'm missing a 0. Oh, well, yeah, but there's a reason for that. It's in math discussion. All right, let's see. Arc length integral. Oh, this is not an arc length integral. 20% of the chats you sent last year. Hell yeah! I feel like I've almost got a monopoly on you. Okay, so question from Doomwood. Transformation R3 to R3, represented by the matrix T, where T equals that. The plane pi sub 1 is transformed by T to the plane pi sub 2. I hate that notation, but okay. The plane pi sub 1 has Cartesian equation. X minus 2y plus z equals 0. Find a Cartesian equation of H2. What is a Cartesian equation? Oh, I guess like is this... Ooh. Wait, what? I know Cartesian is x, y, z, but what does it mean for a plane to have a Cartesian equation? Oh yeah, Yonetta. But okay, okay. I think I understand now. Yes. Okay, yeah. Interesting. I haven't done a problem quite like this before. I know I could do it, but there's probably gonna be a shorter way. Usually r dot product n equals a dot product n, where n is perpendicular to a plane, a is just a normal point lying on the plane. Yeah, Ionetta is awesome. Your other top fives? Oh, let's see. Phobos, Christ United Mission, Brain Mage, James from the Internet, nice, nice. So looking at my cup of tea at all. Yeah, this is an interesting one. Yeah, Ionetta is a person of many usernames. So, okay, so pi 1, ugh. Um, has normal vector 1 minus 2 1. A level for the math? Oh, okay. Um, this plane goes through the origin, so we don't need to worry. Okay, yeah, it would need to go through the origin in order for this transformation to be linear. I think, right? Probably. I don't know. Maybe not. Uh, so we just need to find two vectors inside of pi 1, multiply them by t, and then we have two vectors that are inside of pi 2 that we could then do a cross product of. Oh my god, this is gonna be a lot of steps. There's probably a more direct way of doing this, but I don't know it. It is correct? Oh, okay. So, okay, well, you said, could I elaborate? I think I was talking about the going through the origin thing. Um, this is the most direct way? Oh gosh, okay. That's still very tedious. Yeah, I was thinking that the question wouldn't like if the equation they gave us was instead like x minus 2y plus z equals 1 instead of 0, this question probably wouldn't make sense because the plane wouldn't go through the origin in that case. And so I was just like thinking that part of it through. You posted the answer? Okay. A better way to say that. Yonetta, thank you so much for the sub. Holy crap. I appreciate it. Hopefully your dad does win the lottery, but even if not, that's very kind of you. It would, but you need to parameterize. Um, Either way, it's plane when passed through the origin. T is linear. Yes, okay. Well, I think Fizzbuzz is going to do that, or Fizzbuzz has already done it with computer science, if anything. uh, okay, let me copy paste in what I'm reading from the Discord, just so everyone can see it. Because you probably would rather understand the solution you're given than watch me try to figure it out. So yeah, plane 1 passes through the origin, t is linear, so we don't need to do anything weird to try and make this work, because it's just going to work. So that's our normal vector. Y equals 0, z equals 1. Okay, and so what we're doing here is just getting any two vectors that lie inside the plane. Although, also, by the way, if there's only a certain part that you're asking about, let me know. Otherwise, I'm going to explain the entire thing. But if you're not confused about it, then tell me and I'll skip it. We want two vectors that are inside the plane because those represent the space that is spanned by the plane in the linear algebra sense. So it's kind of weird. We have like a three-dimensional geometry problem that we need to translate into linear algebra terms, and that's what this section here is doing. You just plug in the point 0, 0, 0 and check that it works. So because it's equal to 0, it works out. Like, that's the easiest way. You just like plug in a test point and see if the equation is satisfied. Yeah, exactly. Yeah. And so these two choices here are arbitrary. So there's multiple right ways of doing this part. There's infinitely many. But these look like simple choices. Yeah, it's like choose anything you want for y and z, and then figure out what x must be. So they literally took y equals 0, z equals 1, and plugged it into that equation. And solved that for x. Since it could simplify by canceling the scalar multiple in the end, since it equals 0 regardless in the end, right? Well, yeah, scalar multiples aren't super important, but I'm not sure what you mean by that statement. Like, we can't use any point we want at all. That it has to lie in the plane. But multiples of that would be fine. Dumb physics, math, human brain equals the Holy Trinity. I feel like the human brain's a little bit flawed there, but I could see it. In the end, the transformed line would have... Oh! Probably, yeah. And that should... Yes, that's why they say find a Cartesian equation. Because there are multiple for the exact reason that you say. Completely agree, Dumoed. Yeah, sure. You do. I still got another less than eight hours. But Happy New Year to you, Lucas. Yeah, so like this is a good question to be able to do where you're translating a geometry problem into linear algebra and then back the other way, but it is very annoying. Okay, yeah, so they do ask a different question. So this plane does not go through the origin. Sounds good, Keo. Depending on how long the episodes are, I might not be back, or I might be gone by the time you're back, but I'm not sure. Thank you, either way, thank you for the work. Which under H T is a line? The matrix is symmetric? For the question from before? It does? Uh, I don't see how. Maybe. Doomwood, I guess I was kind of getting lost. I have to wait another. Oh no. Um, would you rather work on this question here, or do you want to keep on talking about the question that we started with? Okay, okay. Okay, so the cross product is useful for this question because um well, okay, let me go back through the flow of this problem. Oh, wait, sorry. Before I do that, let me read Lucas's thing because it was a little bit long, so I skipped it for now. But one thing I find kind of sad about math is that at some point it's more about trying to figure out what combination of known math you can combine to give the right combination, because there's just so much known math it gets shit to try and tackle a problem like that. Yeah, there's a lot of math that's known, and like some of it is really vague also. So you might think you've discovered something just to figure out that someone else thought about it first. Oh yeah, so for this question, the flow of the problem. So where we left off with talking is we found two vectors inside of pi 1, the u and v. We translate those vectors to lie in pi 2 by multiplying by this matrix. And so once we have two vectors inside of pi 2, we need to translate this linear algebra problem back into like a geometry problem. And we need to remember that planes are defined by their normal vector. And the cross product gives you a normal vector to two vectors. Like a vector that's, if you give the cross product two vectors, the cross product will give you a third vector that's perpendicular to both. And that's the exact thing that you want here, because that's how planes are defined. Creating my little cheat sheet for pre-algebra, I was able to pull it from memory. Nice. More so, I mean, stuff I've first discovered happens in trig a lot, which only gives the right first step in order to start solving it. Yeah, like with math, you always start with like a simple thing and you kind of evolve it, I guess. It is a lot to take in. It is a kind of a common theme in math problems like this. So it's good to know, like, if you are given two vectors that lie inside a plane, you can always figure out the equation of the plane using the cross product. And planes are defined by their normal vector. So it's a really good theme to remember. Yeah. Do you have any reason as to why matrix is multiplied the way it does? There is a reason for it. I need to remember it, though. I don't remember it offhand. You kind of want to find a normal vector n such that n times ap equals 0 for pi for every vector in pi 1. But n dot ap, or n times ap, a transpose n times p. I haven't gotten past your first sentence yet, Yonetta. I'm not sure why we want to find a normal vector n like that. Duma, it says, quick recap. I find 2 points lying in the first plane. I then transform those for them to lie in the second plane. I find cross product of those 2 points lying. Yes, exactly. Perfect. And the cross product gives you like these coefficients for your Cartesian equation. That would be the normal vector that describes P2. Oh, okay, yeah, I get that. Okay. But n times AP equals A transpose n times P. If A transpose n equals normal part of pi 1. Normal of pi 1. This solves the equation. Huh. If ATN equals normal of pi 1. Sure. Huh. I find cross product of those 2 points. Okay, yeah. But what makes you sure the 2 points which lie in the first plane are guaranteed to lie in the image of the plane after transformation? That's the entire purpose of T. Like, we're given that T is the transformation from pi 1 to pi 2. So that's just like a definition thing, I guess. Like, every linear transformation is represented by a matrix like that. And so if that wasn't true, linear algebra would be in a lot of trouble, I guess. It's T, not A. Well, T to the T is weird. Yeah, yeah. I figured what you meant with A there. I think you found something clever, Yonetta, but I don't know. I'm having a hard time wrapping my head around it. I half understand the second sentence of what you wrote there, but I'm not quite sure yet. The plane one itself is moved to another point in three-dimensional space, with each point lying in the first plane having a different. Yes, exactly that, Doomwood. Like, I literally imagine plane one like stretching and squeezing and rotating to morph into plane two. That's what this transformation is doing. I don't know. So let me just do it the way that the non-clever way that I think Doomwood is supposed to do it. I think Yonetta found a cleverer way of doing it, but it's too sophisticated for my caveman brain. Actually, I think maybe just asking about the process. You don't need to actually see it. I don't know. Let me let you write what you're about to say, and then we'll figure that part out. 1. Find 2 points which lie in the plane, transform them, and find the cross product of them. Yes. I assume there's a part 2 coming here. Maybe while I'm waiting to see that. Oh, no, here it is. 2. Find the vector equation, which is r times n equals a times n, where a is a point lying on the plane, r is a general point of xyz. A is a point lying in the plane, r is a general point of xyz. Oh, yes. Okay, that's equivalent to the way that I learned it, I think. The way that I learned to do your step 2 is just using the point normal form of a plane or whatever it's called. But like I think the general equation for a plane, if you know the normal vector and a point that the plane contains, you can use this equation to get its formula. Oops. And I think what you've written there with the rn equals an is the same. It turns out to be equivalent here. suppose this is somewhat confusing. Yeah, that's the part that I'm confused on, I guess. Think of x dot y, the dot product is x transpose y. Then x dot my is equal to x transpose my. Well, the associativity is also throwing me off there. I guess these are all dot products. You're just only explicitly writing the dot product sometimes. Well, I guess, like, I don't know. It's like the associativity. Yeah, no. Harrodson, you can try. I'm probably gonna wrap up things soon here. And I feel like oftentimes people try to show me the thing they made, I can't make sense of it. You can try me if you want, but yeah, I don't know. I'll Dumud, yeah, I appreciate if you didn't use that word in particular to like as an insult. Uh no worries. I know you don't mean anything bad by it, but yeah. The plane through non-collinear points A, B, and C as vector equation. The plane through okay, yeah, A, B, and C. Oh, these are vectors pointing to A, B, and C, I guess. Really? What are lambda and mu? What it does here, it denotes B and C kind of like X and Y in a 2D plane. Huh. I don't see it. You write it as X transpose Y, you can think of it as a 1/3 matrix times 3/1 matrix. If you okay. Sounds good, Harrodson. Okay, Doomwood. That's true. Yonetta. And I'll go back to reading your thing in a second. I just want to focus on stuff that Doomwood is posting because it's more like relevant to how Doomwood is supposed to do it. Oh, the vector equation of a plane. Okay, yes. Yes. I have seen this. Okay, yeah, I know this. And so what are you doing with this now that I understand? Let me see. Because this isn't the Cartesian equation. I don't think. From that, you let r equals x, y, z. That was taught to change the Cartesian into that form of the vector equation with parameters mu and lambda. But yeah, so I think we basically, once we multiplied the two vectors by t, we have the b and c here. And we can choose a to be the origin because this transformation maps 0 to 0. So we know that the second plane passes the origin also, which I guess the answer key says at the beginning. I don't know if you can go directly from this to the Cartesian equation though. Like I think you need to use the cross product. I guess you can post it in the Discord. All right, Doomwood. Okay, going back to Yonetta's. Textbook looks nice. Yeah. NAP, but NAP equals ATNP equals 0 if ATN equals the normal of P1, pi 1. So oh, wow. I think I finally understand now, Yonetta. Um, dot product xy is equal to transpose x times y viewed as matrix multiplication. XMY equals transpose XMY equals transpose MXY. Okay. Which in turn equals transpose mx y, given our definition. Suppose it was a weird equality in the previous text. Yeah. So that's really crazy that I don't know why, or I guess I mean, you explained why, but like what the intuition is for solving this system of equations, giving you the exact thing that you want. You still have to deal with a system 3x3 system of equations, but huh. That's really clever, and this all hinges on the t that they gave us being symmetric. I think maybe we could deal with it if it wasn't. Someone expected in the sense as well. Someone transform the normal to get the new normal. Okay, yeah, okay, that's a nice way of saying it. Transforming the old normal to get the new normal. Oh, okay. Well, no, but then we would do t times the normal. Huh. I don't know. To transpose ax equals previous normal. Okay. Yeah, that's fair. Um oh, sorry. Do I posted a new thing to look at? Or another screenshot? That might be helpful. This is another. Oh no, it's almost symmetric. It's barely not symmetric. Okay, this is a little tedious, but it's doable. This makes sense. Um, 0 lambda part. Cartesian equations of the image of AHR. Yes. That y equals z plus 12 equal lambda. What? Am I crazy or did they just divide by 0? maybe they're supposed to. Uh I, that's supposed to happen, I think, because the image should be a line. So one of these equations shouldn't make sense, I guess. That's really... I don't like the way this is explained. So, um, yeah, they're trying to force these Cartesian equations to match this form here. And so the way they did that, I guess, was letting the equation with y and z equal to lambda. And then they took x equal to -6, rewrote it as x plus 6 equals 0. And then they said that 0 is the same thing as 0 times lambda. But that's really wild because of the next step that they're about to do, which is saying x plus 6 divided by 0 equals lambda, which is just wrong. But it gets lambda equal to something involving x is what they wanted all along, so they could write this. I think they're trying too hard to make this general rule they're giving work everywhere. Okay, yeah. That's fair. There's no excuse to divide by 0 in my mind though. the the reason it comes up is that it kind of flattens, it takes a 3-dimensional plane and flattens it into a 2-dimensional line. And so there is going to be some sort of weirdness like that. Like that's the reason why the 0 comes up. They shouldn't have presented it like this though. Yeah, that is pretty unhinged. Kind of weird. I don't know. I was just thinking the song sounds familiar, but not quite. It's like I can't remember the name of the song, but it's like a remix of a famous song, I think. That's used in like movies for epic moments. Okay, Avengers Endgame, Tony will snap us into the new year. Some white girl music. We can get Taylor Swift back in here. Okay, so Doomwood, are we okay with this problem now? And I can take a look at what Harrodson put in there. Oh my god, Harrodson. This is this is kind of long. I'll see what I can do here, but I can't read this entire thing. Or at least I won't read this entire thing. It's maybe more accurate. Sounds good, Doomwood. Thanks for the question. Um, Good night, Doomwood. R and B. I don't see R in this list, but at least B belongs to Y, belongs to K. W belongs to X. I don't see Y in the list either. R is real numbers? Okay. ChatGPT removed it? Oh, okay. Elements of K minus R are not numerical sets with a classical axiomatic system. If it isn't /LaTeX, I'm unable to read it. No one axiom 4% in the system. I made it clear axiom is scattered throughout the text. Oh man, I don't like how Discord is showing this, but it's not your fault. Why is double numbers? Oh, maybe dual numbers? Like, okay. Marked by star for axioms. The part of the star works on will be marked by vertical bar. Tertiary numbers and the cent operator. Tertiary numbers arise an extension of the traditional sign game. In the classical system, the sign game behaves like this. Same thing, but don't... Oh, it's not the same thing? Okay. Plus plus equals plus. Minus minus equals plus. So, okay, this sounds like multiplication for positive and negative numbers, but... System fails when trying to solve equations like x. I can't read that character. Is that squared? Probably x squared. Therefore, tertiary numbers offer an alternative to I. Or maybe that's cubed. Which only sacrifices the sign and not the numerical value. It is squared. Okay. Okay, so this is an alternative to complex numbers that you're saying. And so we're about to say what... We're introducing a third sign that isn't positive or negative, I guess. Is that what's happening? So cent is minus. Yes, kinda. Okay. Cent plus is cent. Cent minus is cent. Star. So it's an axiom. Plus cent equals cent. Minus cent equals cent, which follows from this axiom, I guess. So pluses just always get eaten? Okay. Unless it's plus plus, I guess. I assume these previous ones still hold. There's divided by 0 thingy. Okay. The first allows negative squares. They'll simply transfer the value to tertiary numbers in any case. So the abstract therefore has no justification for any different result. When multiply tertiary numbers, if only one of the factors is tertiary, the result keeps the cent sign and the numerical value follows normally. If both are tertiary, the result becomes negative. Thus, the operation preserves the tertiary nature while respecting the interaction of signs. Huh. Okay, yeah, I think I see what you're saying, and that's not sentence, but like this like section. Five times 2 cents. I'm just gonna call it as 10 cents. I guess so far, I don't see how it's really different from I. But maybe that's about to happen down here. The tertiary operation is defined by A cent B equals cent A. I don't know what that symbol is. Or that. Oh, I guess are these Greek letters? Or what? Or is that just. Wait, what the hell is this? Okay, this definitely makes no sense to me right as of now. But A cent B equals cent A if A is any non-zero real number and B is any real number. A is any non-zero. I'll just believe that. When 0 cent B equals 0, there are other numbers outside the set of reals with properties that bypass this rule. Be addressed later. 1 cent 1. 1 plus 1 plus 1 minus 1 over 2. Oh, there's supposed to be a line break between these two things here. Minus 1 cent minus 1. Oh god. Okay, yeah, I definitely won't be streaming for another 2 hours. Kyo. Enjoy. Thanks for the lurk. Yeah, see you around. Okay. I'll ignore the calculations then. Where else to tell you what the new year looks like, and if your dad becomes a billionaire. No, I'm getting tired and hungry. Um, since this object cannot be zero, we introduce epsilon. Oh, okay. So you found some weird case where something seems to equal itself divided by 2. And so you're going to call it epsilon instead, which is like, this does make me think of dual numbers. I think that's how they're defined at least. Go big if it happens. I'm talking Karambit, Doppler, or better. Oh, there you go. Yeah, CSGO skins are a good investment for retirement. Pseudo dual because you can take the root of it. Okay, I know almost nothing about dual numbers to be honest, aside from they look something like that. uh the C the scent will look quite different from imaginary numbers after the double number section. Oh, the music just stopped. Um, I can almost Harrison. I'm getting really like lost. Like I'm feeling very out of my depth. This is not a type of math that I'm good at. Anvil by Lorne? Sure. It's okay. You you're not the first person to show me like something new that they've thought of and they like want to talk about it. And that's awesome. Like I want to encourage people to do stuff like this. I just never know what to make of it because I'm I just like differential equations to be honest. But it is awesome that you've like gone this deep into this stuff. I'm just more of an applied math person. Uh you invented a solution for x over 0. Can see division by 0 down here. Corrupted unit? or x times 0 equals 1. Perp. We're trying. I'm pretty lost in the thing that I'm reading right now, but I'm trying to understand it. I hope you're doing well. Point to the left is negative. Now from the 0 point, construct a ray coinciding with the line. Coincide to the positive side, rotate it 90 degrees counterclockwise. Coincide to the negative line, rotate it 90 degrees clockwise. Any point located on this ray is considered tertiary. On the second term to effect the tertiary operation, give up on real numbers. This result tends to be redundant. I then present the RC plane in double numbers. RC plane, real corrupted, is a two-dimensional algebraic structure where each point is a double number. The corrupted and real axes are actually parallel and represent orthogonally to visualize double numbers in a two-dimensional field. The overlap of 0, the 0 represented by whatever that symbol is. It looks like a frog to me. I doubt it's a frog, though. Okay, so D is some element of the RC plane. Looks like A plus B, whatever. This is where it gets interesting. Okay. A belongs to R. Abscissa, real part, horizontal axis. B belongs to R, coefficient of the ordinate, corrupted part, vertical axis. B corrupted part is not a subset of R, or non-element of R. It's kind of funny because Lucas was trying to do something kind of like this with division by 0, but this seems a lot more sophisticated, I guess. Measuring your ability to understand this 20 minutes of taking 2 tequila shots. Oh, I would do much worse. that would be fun though. No worries, Fembox. It's a good song. Two-dimensional number, you can manipulate the part using only monomials. That's true. I personally, I'm not much of a New Year's person. I'm not much of a holiday person in general. I know, to me, it's just kind of a date on the calendar. I never cared too much about it. Fuck having fun. It's math, baby. It's exactly what I said. B loses. Corrupted part goes to the abscissa axis. A gains. Corrupted part goes to the ordinate axis. D is a point in the RC plane. Corrupted unit. Whatever. It's equal to 1 over 0 is not real, but a number operator hybrid. Main properties. Idempotent. Sounds good, Ionetta. Good luck with your organization. If you raise it to a power, it's equal to itself. Sure. Okay, yeah, sure. The square root. It's equal to itself. Okay, sure. Billion would help. Be able to buy as many bookshelves as you like. Provided you don't buy more than 1 billion bookshelves, yes. And people to organize them for you. Oh, you won't. Oh, never mind. Okay. That's fair. You only said you want to organize your bookshelves and desk. You didn't say you're necessarily going to. But I assumed that meant that you would have to, like, leave the stream. But no, I want you to stay. Hey, BR Gaming. directs corrupted unit in the following way. Oh god, like 0 over 0 equals 1? Oh yeah, that's fair, Yonetta. It definitely is. Happy New Year to you too. Christmas is like the one holiday that I care at least a bit about because it's just kind of fun. I'm not really religious, but yeah, I mean, this is definitely weird, but as long as we're doing this, there's no reason we can't do it, as far as I know. Zero is the origin of the real axis, not universal. Okay. Zero is the origin of the corrupted axis. An element. Oh, zero. Okay. So we have two different zeros. Oh, that's okay. Yeah, that's your dual number thing. Okay, okay, okay. Or a pseudo dual. Kinda? Okay. AX equals A. Zero satisfies both equations simultaneously. Huh. Each origin only nullifies its unit. When the RC plane is a double number. Pure corrupted or mixed. Sure. Let me correct something. Okay. I know that means deleting the message or what, but okay. But I'm just gonna keep on looking at this part. Oh, it's actually we're almost at the end. Not paying much attention to the question at hand. Here to know if the systems he is describing are fields, groups, rings. Yeah, I mean, I guess that's a better question for Harrodson. I would assume they're not because there's not a single identity. Like we have two different identities going on, but I'm not someone who really knows algebra, so x times the corrupted unit is 0, not the corrupted origin. Okay. It's the only thing wrong for now, I suppose. Okay. Hmm. Okay, I'm just gonna kind of skip past like a chunk of this here. Yeah, calling it corrupted is kind of fun. Oh, hey, okay. I think Yonetta, this is the answer to, or at least maybe addressing your question. The RC plane does not attempt to compete with classical fields, rings, or extensions. It is already born outside this paradigm. The central point is that the system is not defined by universal laws, but by contextual operation regimes. Things are valid in it when the algebraic orientation makes sense. So it sounds like the short answer is no, it's probably not any known algebraic structure. Determine the tertiary operation can finally affect the final result. Huh. Larger or smaller. I guess, yeah, these might not have like a meaningful magnitude. Some sorts of cool names for groupoids were once called magmas. Ooh, that is cool. Tetra numbers. Partially tertiary double number. In one tertiary part, corrupted or real, subordinate to another value. Corrupted tertiary part. Numbers are represented visually, extrinsically, in a four-dimensional space. In this space, corrupted lines and real lines remain orthogonal to each other with origins coinciding so that both the real tertiary ray and the corrupted tertiary ray are orthogonal to any other line or ray. Okay, well, I guess I lied. I did sort of read the entire thing. Skipping some parts and not understanding most of it, but we did at least get to the end. I don't know, Ayrton. I have a hard time giving you like a helpful feedback here. I think it is interesting that you found something that can get solutions to dividing by zero potentially. And I like your names for it with calling them corrupted numbers. Yeah, I don't know, like someone else in the Discord may also like have a read of this and be able to like speak to it better or have like better thoughts for you. So I wish that I could like engage with you better on this, but like I said before, this isn't my forte. Look up, apparently what I call a groupoid is called a groupoid in some sense. What is called magma, though sometimes called a groupoid, is more commonly a magma still. Oh, okay. It's one of those things where like there's disagreement about the definition. But yeah, I don't know. We might leave it there. But I guess like, well done. Like this is definitely way more than I could do with this or you've done way more with this idea than I could do. So respect to you there. Groupoid is a category in which all morphisms are isomorphisms, and a group is a groupoid with a single object. Ooh. Hey, Richard. Nice. Welcome in. ChatGPT ruined a lot of text. Yeah, I can tell. I was kind of overlooking some of the weird like formatting stuff and all that, but that also makes it harder when it's originally written in Portuguese too. Yeah, I don't know. I guess nice like exploration. Not everything in translation is analogous to what I wrote. Okay. Yeah, that's always a hard thing. Rigid comes from the future. It's true. I do think I want to wrap it up though and get food because I am getting pretty hungry. Rigid, we were just looking at a thing that Harrodson wrote there, about like what if we tried really hard to divide by 0 and make it work. I'm about to wrap the stream though now. We were also talking about linear algebra beforehand, but this will be the end of it. Sounds good, Harrodson. Sleep well. Thanks for sharing your work. Yeah, that's gonna be it for me too. So Rigid, Harrodson, and Osuzi here on YouTube. Thanks for being here. On Twitch, we'll look for a raid. But praying for JE. Good luck with that, Rigid. It seems insane. No worries, Harrodson. All right, see you, YouTube.